Okay, two things you should know about me. One is I cannot speak and stand still, so I'm moving around a lot, and I apologize if that's distracting. The other thing is, I have a tendency to talk rather quickly. Don't worry, I'm not having a hypomanic relapse. But if I really, really lose you and just go for one, you stick up your hand and ask a question, and it'll shut me up. Okay, so, disclosure. I'm part of the National Neuroscience Curriculum Initiative in the United States. Along with my co-chairs David Ross and Melissa Arbuckle, about whom I'll speak more later on. We're funded by NIMH and also by the Society of Biological Psychiatry and the American College of Neuropsychopharmacology. So, this journey, if you like, started with a blog by Tom Insel, who was then the director of NIMH. And he wrote an op-ed saying, the future of psychiatry equals clinical neuroscience. And this had a real resonance with us, because when you look at the literature over the last sort of 20-odd years, you see this truly exponential rise in publications with the words psychiatry and neuroscience in the publication. And it's amazing. And that takes us up to 2012. But if you look at 2012 till now, it's even more exponential, as if that's possible. And so this is why it's crucial for us to be thinking about how we're going to integrate this modern neuroscience into our everyday clinical practice. And one of the barriers that we faced when we first started this is that perennial one of, it's not ready for showtime. The clinical neuroscience isn't ready for what's going on. Well, this is highly futuristic. Absolutely highly futuristic, but there are already artificial vision systems coming online. People are able to plug things into their brains and be able to see. Okay, this was supposed to start automatically and it hasn't. Oh, joy. Oh. This hopefully is familiar to almost everyone in the room. Okay, highly futuristic.
I know you handshake, but we got to the point where we can do press bumps. Let's see.
This is in the days when we still had a president.
Well, Nathan is moving this hand with his brain.
And what's really fascinating about that is that's a closed-loop system. It has sensors on it so that it didn't crush the president's hand. It's phenomenal the way that things have moved on over the last few years. We're able to look at cells as they're actually functioning, as they're doing things. We can manipulate the brain using optogenetics. Admittedly just in rodents, but it's getting more and more. We can look and take pictures of processes happening in real time at the microscopic level. And this is really telling us a lot about what's going on in the brain and what's possible for us to do. We have brain interfaces that are external. We don't have to poke a hole in the brain anymore. We can stimulate things. We can do all kinds of stuff. Now that may not be the right vision for what we want to do, but it's there. It's technology, if you like, that's sort of science fiction-y, but it's also being utilized in clinics. It's also being thought about for ways to manipulate the brain in real time in the scanner in the same way that we're able to do in rodents. We have the whole epigenetics phenomena. And epigenetics is that key thing. And I remember when I was a trainee, it was like, okay, there's the environment and the genes, and there's the gene-environment interaction. Well, how does actually one work on the other? Well, epigenetics can help to explain that. Pharmacogenomics. As we heard this morning from the excellent talks that we're doing, we're getting closer and closer and closer to thinking about disorders in terms of their pathophysiology, of thinking of ordering a test so that we can see which treatment is going to be better for an individual. This is a really, really, really important time for us to be thinking about this stuff. And at the same time, we need to, writ large, do what we've all been doing as clinicians forever, which is, okay, this person has a diagnosis of schizophrenia, but they have some mood instability. So I will probably end up giving them a mood stabilizer. They have some depression. So I'm probably going to give them an antidepressant at some point. We've all been thinking dimensionally about our illnesses. And if, as we go forward, the more that we think dimensionally about them, the more we'll be able to move away from those kind of categorical diagnoses like schizophrenia, schizoaffective disorder, and bipolar disorder, and put those groups together and then look for the pathophysiology that underlies the symptoms that the individual patient is experiencing, and then split the groups up by biotypes or endophenotypes. This is happening. This is work that's going on in a lab that I'm involved with in Pittsburgh. This is work that's going on in a multi-collaborative study out of Yale. There's tons of stuff. There's tons of stuff going on in Europe and in the UK, looking at precisely these things. We're also getting much, much better at looking at genetics and looking at how genetics can lead to a variety of different symptoms. And one of the major reasons why in the US they switched from sort of autism diagnosis with Asperger's to autistic spectrum disorder was because it's been estimated that every year 1% of people with autistic spectrum disorder are taken out of that diagnosis because we found a gene or a disorder of metabolism that's causing their autism. And we're in an age where with things like Cas9, we can intervene when genes go wrong and put new genes in. It's a scary prospect. But it's a prospect that we as physicians are going to be facing in patients that we're going to be seeing. Somebody with an inborn error of metabolism is going to have a gene, new gene spliced into their genome, and then we as consult liaison psychiatrists perhaps are going to be called to see that individual when something else goes wrong. And we're going to need to know about those things and need to know about what it. And so our rallying cry, and this is a paper we published in 2016, our rallying cry was, okay, the future of psychiatry is clinical neuroscience. Why the future? Why not now? We know enough to be able to use a lot of what's going on in clinical neuroscience actually in the clinic, in terms of explaining things to our patients, in terms of our understanding of what's happening inside of our patients' brains. And for me, this started when I was a researcher at the Institute of Psychiatry. I was a research assistant, young, sort of going out, recruiting people for my brain imaging studies in schizophrenia, and I was doing 5-HT2A imaging. And I would go and see patients with chronic schizophrenia who were on various different drugs, and I would do this long explanation of what was happening at their 5-HT2A receptor, and go through the whole consent process, and I was like, this is a waste of time. This person does not understand anything I'm telling them. And then I had one of those rare epiphany moments. I went to see someone for a 3-month follow-up. And he said, oh, Dr. Travis, that 5-HT2A blockade I've got in my brain that you showed me. He says, that's bloody marvellous, that is. It's brilliant. And forever afterwards, I've gone into quite complex discussions with my patients at the right level of complexity for them about what the medications are doing in the brain in terms of reducing phasic dopamine release. It's important. We know stuff that we can use, but there are barriers to us teaching this. You're lucky. In the UK, your accreditation body has gone and got a grant to fund a panel to help include neuroscience in education. In the US, it's quite different. We have a thing called the ACGME. They accredit and set the program requirements for psychiatry in the US. They have a thing called the Psychiatry Program Requirements. It has a lot of words in it. And there's a lot of words like must, and core, and resident, and outcome. The word neuroscience isn't mentioned at all. Not once. They did something to address that when they did the Milestones project. And they did a thing here called the Clinical Neuroscience Milestones. Unfortunately, you won't be able to read this, but when you actually look at this, this is not clinical neuroscience. This is, at best, neuropsychiatry, but it certainly isn't clinical neuroscience in the way that we understand it. There's also this tension about, well, how do we understand our diagnoses? You know, this is the kind of traditional way when you're putting a teaching course together. You want to teach about PTSD, so you'll have diagnosis and phenomenology, you'll have maybe a bit of neuroscience, CBT, psychopharm, and in the US, very much the psychodynamics. You know, and then you have sort of social treatments and everything like that. And they'll all be sort of separate modular things. And really, we ought to be teaching this in a different way. We ought to be thinking about PTSD, the neurobiology, in terms of, as we heard this morning, the frontal cortex and the dysregulation of those pathways, thinking about how that might be affected by exposure therapy, and how we might be able to enhance the exposure therapy by using sort of the enhancing the plasticity of the brain, and then blocking reconsolidation. And these are all concepts that are useful to think about, and integrating that with cognitive therapy and then social therapies and supportive housing. And that is, in many ways, a much better way and more realistic way of conceptualizing a patient with PTSD, is bringing all of these different things together in an integrated fashion. And that's really what this is about. It's about integrating everything together. And again, as educators, as people who are going out and trying to tell people about this, there are some key questions. What should we actually be teaching? What are the key things that should be going into this? Where does it fit in to what we're teaching? Importantly, who's going to teach it? And most importantly, and this is something that really, really drives us, is how do we teach it well? Because you can teach for hours. My residents have 3 hours a week, that is dedicated for their teaching. How much do they learn in those 3 hours? Well, if we don't do it right, not very much. So, the traditional model of medical education is that we have sort of central regulations, and then they're implemented by individual programs or individual training schemes. And that, I want to put it to you, that doesn't really work for modern neuroscience, because there's so much variation between different places. And so, when we think about this, we think about how do we teach neuroscience, okay? Well, this morning was a wonderful example of having neuroscientists come and do education, conducting cutting-edge work and able to put across a story really, really well. But we need to have that training there kind of all the time, and getting these people to come and do that may not be possible. And also, you will have experienced this, I'm sure, in other meetings. Some of our colleagues are not the best communicators of their cutting-edge research. And sometimes it cannot seem relevant to what we're doing. So how do we teach it well? Well, people who are educators because they can teach. But they may not know or feel confident enough, and that's the most important thing, feel confident enough about the content to feel that they can really, really teach it. And so we think of this as the content and the process, or as I have to say on the other side of the Atlantic, the process. And it's really, really difficult to try and get the two together. So one of the other things that we think about a lot in terms of improving education is there's a wealth of literature now about adult learning and how to get adults to learn. And if we're going to do anything, we need to use those principles in order to make sure that when we're teaching effectively. I'm specifically talking about teaching neuroscience to psychiatrists effectively. And that's what led us in 2013 to join and form the NNCI. And there's a whole load of serendipitous things that have happened to us over the years. The reason we got together at all was complete serendipity. Melissa had been asked to do a one-day pre-meeting for a meeting. Dave, Ross and I had met about 2 months beforehand for the first time, got on like a house on fire, we're collaborating with each other. Then Melissa said, do we want to get involved with the conference with her? we then found that we really got on very, very well with each other. Then somebody else heard about us doing this brain conference and then recommended us to NIMH, and then NIMH. And we've been going now for 5 years. Our aim always has been to create a set of open resources that will help improve the teaching and integration of neuroscience into modern cutting-edge psychiatry. That has been our overriding principle. And, again, serendipitously, I was at the American Psychiatric Association meeting. We were presenting stuff to do with the NCI. We were sitting in a hotel lobby having a meeting about the stuff that we were doing. And this bloke comes and sits next to me. And I thought, I think I know that bloke out the corner of my eye. We got on with our meeting. And I turned around, and it was Simon Wesley. And Simon says, "What are you doing?" I said, "Well, we're having this meeting about the National Neuroscience Curriculum." And she said, "Well, what's that?" And I said, "Oh, it's this thing." And he said, "We need some of that." Hence the reason why I'm here today. Again, serendipity. It's wonderful. And this, again, is one of the things that's happening through the Neuroscience Commission here. You already had the sort of Tron initiative that was going through and providing teaching resources for you. And now we're able to expand out on that, look at the way the curriculum is coming together, look at the questions that are in the Royal College exam, and then try and build these together into a direction in which we want to go as psychiatrists. And I just want to shout out here for Melissa and David, some of you had met new ladies here yesterday. These are some of the events that we've been sort of doing this work at over the last few years, and this goes up to September last year. We've done ACMP since then, and I did Grand Rounds in Alberta. We have an advisory board headed up by Jane Eisen, and these are people spread out throughout the US. They're all training directors of different sorts of programs, and they advise us about what we need to be doing. And so, just to give you an idea, our idea with this always has been that whatever we produce, whatever we put out there, has to be patient-centered. Virtually all of our resources start with a patient vignette or something that can be related to by the learner. We have to teach it well by applying the adult learning theory, and we want to create things that can be used by anyone, anywhere, with any sort of resources. And we don't want to tell people what to do. That's a slight difference between sort of us and the States. And here, where the Royal College has the capacity to be able to tell you what to do, but more importantly, we have to want to do it. We all know that as psychiatrists. We can tell people what to do, but we have to really try and make them want to do it. And so, the other part of this, which we think of as the INSIL objective based on Tom's blog, was that we want all trainees and clinicians to incorporate this perspective in every component of every formulation and patient care. It's a tall order, but it's actually quite important to do that. So, our classroom teaching stuff is rooted in principles of adult learning. It's easy to implement. And we try really hard to make the stuff that we're doing fun. There is no reason why being taught has to be miserable. I wish I had known that 25 years ago. But there really is no reason for it to be miserable. So.
Hello, my name is Josh Gordon from Columbia University.
Many of you may know the name Josh Gordon. Josh came to our initial tryout for the Play-Doh Brain and for the Brain meeting. We've just begun the NCI. Josh turned out to be a complete whiz at making body parts out of Play-Doh, starting with the brain, moving on to do feet and hands and everything like that. We had him do a new video for us. He is now the director of the NIMH. You too could reach such busy. Oh, sorry, killed the video now.
Hello, my name is Josh Gordon from Columbia University, and I'm going to show you how to build your brain out of Play-Doh.
Follow this closely. follow that? There's some Play-Doh at the back. Okay, we come up with other things that are, trying to get people to think about stuff. So this is one of my favorites. I'm not going to play the video, but this is a really, really frightening video that gets everybody like on the edge of their seat and stuff like that. And then we ask people straight after that to draw the pathways that underlie fear and anxiety on a paper brain. And then we show them a resource that explains what the actual pathways are, and then get them to draw them again. It's a really, really good way, because you're up the Yerkes-Dodson curve because of this, so you really learn this stuff. And it's fun. The other thing that we're trying to do is to get this to be integrated into all of the rich traditions that we already have. Because if it's divorced, if it's a separate thing, and now for the neuroscience, we're not going to encode it, we're not going to remember it, and crucially, we're not going to use it in the clinic. And so this is a thing that Integrative Case Conference is, again, you discuss a case, you have a really, really good discussion about case formulation in terms of the way that we understand it now, which is really fun and gets everybody up to speed with what's going on with that disorder. And then you have a panel of experts, and it can be just two people covering this, but they cover a bio, a psychological, and a social formulation with a real attempt to integrate the three things together as part of the open discussion. It's a very, very powerful way of getting everybody to learn about a specific disorder. And so we've been doing this for years. There's 4 or 5 of these up on the website, and there's me at the top being the bio expert for the tryout that we did. It's a great way of re-engineering case conferences to be more neuroscience focused. One of the other modules that we've come up with, which has had a huge take-up because it is easy to do, it's highly relevant, and it can speak to stuff that's going on at the moment, is the neuroscience and the media module. And this is, again, based on this idea that we should all be ambassadors of neuroscience. We should all be there when people are sort of saying, what is this thing I just read in the paper? What is this thing I just heard on the radio? What is this thing I saw on the television? And we can explain it to people. And the idea of this is that you take something from the popular media, whether it be a newspaper article or a magazine article, or something that appeared on the Today program that morning, and you review it as a group, you appraise the media portrayal, then, and this is something that I've been trying to do for ages, you get people, you get people to get their smartphone out, and rather than texting and emailing each other while we're trying to teach them, you get people to actually access the original resource on their device, which is actually fun. And if you can't do that, then you just hand out the literature, and then you appraise that, and then you role play, trying to communicate that to a lay audience or to a patient. It's actually a lot of fun. We have a thing up about Radiolab using TDCS to make someone do better in a shooting game. It's very, very good. They've done a fantastic job, and the actual literature behind it is also fascinating. And it's a great way of getting stuff across to people, and importantly, getting people to want to go and read more, which I think is a really, really, really important thing. And that's sort of me teaching it. And then there's translational neuroscience. Translational neuroscience, I loved it. Translational neuroscience, you take 3 short papers, and you split your class into groups. They get a paper each, and they have to discuss it. And then they have to, on the basis of a case report, come up with the standard of current care. So again, you're teaching about standard of current care, pharmacology, psychotherapy, whatever. You're teaching standard of current, and you get them to read the 3 papers, which are about cutting-edge new treatments that are coming along. And you get them do this on a whiteboard or something like that, and get them to say, what's the summary of this paper? What are the main take-home points? And then not trashing the paper, but what's cool about this paper? What's this going to tell us about in the future? What are the limitations? How does it speak to further treatment? What do you want to know more about? And you can use this as a springboard for the next class. We've also done a thing called Neuroscience Lab. Neuroscience Lab was based on the idea, remember in chemistry, when you had that really cool teacher who would make things explode? We want to try and recreate that, because that unexpected side of things really helps you to do stuff. So we've done things like expose people to doing an fMRI paradigm. and then looking at their own reaction times, and then having an explanation about what was going on in their brain while they did this. I'm very fortunate in this, is that I have a neuroscientist at home who can come and make videos for me to do this. That's Mary Phillips. We've also done this stuff. This is a thing called Articulate, which is a great way of putting a sort of slide thing together with audio and video files and having it as a standalone module or session that people can do on their own. So what I do is I get all of my residents to download this on their tablets, make sure they're all connected, and then just let them get on with it in pairs and be there as the tech advisor. And they learn all about cognition and schizophrenia, all about gamma synchrony. They learn about the pathways in the frontal cortex with questions and answers at the end. And everybody's happy. I've done a lot of other stuff in the classroom as well. Cut and paste clinical pathology is where it's actually really go and look at the website. It's fun. Neuroscience Lab, we've got progressive case conference as a way of drip feeding increasingly complex things to people, so it's not a big brain dump. They, you slowly but surely build in the progressive case conference. And the thing that we've been doing at scientific meetings over the last year and a half is coaching people to do T-circs. This stuff is really cool. The S didn't really originally stand for stuff. But it's a really cool way of helping us as educators learn some neuroscience and then be able to put it across to people in a really nice story-like way, but then also taking people whose core interest is science and getting them to be able to put their ideas across in a 7 or 8 minute talk that really resonates and is memorable to audiences. And there's much more on the website. So, have we been successful? We thought so, but we started to reflect. There's about 100 hours, 200 hours of classroom teaching in American residencies. But there are 9,000 hours in the clinic. And our big fear was that people were not learning neuroscience in the clinic. So we came up and repurposed some other modules, including talking pathways to patients. Because this, to me, this is how I started out. This, to me, is the key thing at which we can use the neuroscience for at the moment, is actually explaining to our patients what's going on inside of their brains. And so you watch someone demonstrate it in the classroom. You then demonstrate that to each other, one playing the patient, one playing the physician. And then you importantly switch roles and learn from each other. It's a very powerful way of learning the neuroscience. And again, it's always based on a case in the beginning. We also had the clinical neuroscience conversations, which is a similar sort of thing. This is a Dutch footballer taking a dive. He's a sort of a thing for a malingerer, and we have a module on sort of malingering and the changes in the brain that go with that. But again, it's to help people to think differently about different disorders. And it's something that you can do in the clinic with your trainee. That's the idea of it, is you look at a video resource that lasts for about 4 or 5 minutes, and then you can discuss it and use it as a teaching point. Or once you've done it 2 or 3 times, you can actually do it in the clinic yourself with the more commonly seen patients. So, there's also a broader audience. As the more we've been doing this, the more we've realized that really this isn't just about psychiatric trainees. Here's a psychiatric trainee. You can tell it's a psychiatric trainee because they're very happy. They haven't yet become a consultant. But we realized that actually we had a whole load of people who are teaching medical students come to us and say, oh, can I adapt this for medical students? The attendings, we need to bring the consultants and the attendings up to speed. When I was standing up here at the beginning, when we were sorting everything out, I heard somebody in the room saying, oh yes, this is great for trainees, but what about all the faculty that we need to do faculty development with in order to get them up to speed, in order to get them to teach it? We're really on that. We're doing the 3rd course that we've done at the APA next in a month's time. There are other MDs. It's amazing how behavioural health is coming out to other specialties, and they want to know our stuff. There are PhDs that need to know this stuff. We have, and when I left the UK, there really weren't physician extenders. Now, obviously, that there are, they need to know this stuff. And obviously, our patients and our families need to know this stuff. Because it's really empowering for people to sort of say, I'm taking this treatment because this is what it's doing to my brain. We've also done quite a lot of outreach to other things using social media. Again, realizing that that's where people are accessing us from. So, where are we at? Well, part of the reason why we were so excited about the collaboration with the Royal College of Psychiatrists was to be able to share resources backwards and forwards. We have a lot of resources on our website. There are a lot of resources in Tron. There's a lot of good thinking going on around the way that we're educating these things. So we want to build a learning collaborative around that and reach out to other professional organizations like the APA for us, SOVP, ACMP, and the college. Because again, working together, we're much, much more likely to be successful than working in our own little silos and all trying to do the same thing. We also do a lot of outreach at conferences and with departments. So anyone comes to see us and says, we want to do this, please can you help us do this? We will help them. These are some of the places that we've been. So one of the things that we want to do today was also tell you a little bit about the website. The website, I'll put the URL up later. The website has links to all of the resources that I've shown you, plus a whole load more. We also have these Neuroscience Lab reviews, which are non-partisan reviews of the literature about complex subjects that are easy to read. We also have a load of short video talks by experts in the field that we nabbed on the way to the bathroom, ACMP and SOBP. We also have other neuroscience in the media things. We also, host, if someone wants to do an Integrative case conference and broadcast it, we will host it for you. We really want to have more and more resources there. So just so that you know what's there now, we have at least 10 unique modules. Module is a way of teaching. If you put new content in it, it becomes a session. And we have at least 60 sessions. We've got 100 sessions now. They've been written by 60 authors from at least 30 different institutions. And some of you may know, we're publishing online and free to access clinical commentaries, which are essentially neuroscience education commentaries in biological psychiatry every 2 weeks, which are really, really exciting. The website's had 2,000 US cities have visited us and 149 countries. Here are the other stats here. It's really, really gaining momentum. Most importantly to us, we've now reached critical mass in terms of the number of programs in the US that have used our stuff. There are about 200 programs in the States. And we've had 100 plus use stuff from the NNCI as part of their curriculum and their teaching. And again, being here is part and parcel of that effort. And we're hoping that we will be able to synergistically work backwards and forwards with the people doing Tron and really, really help to develop a curriculum that's really meaningful for 21st century psychiatry. Coming along the pipe, we've got a small business grant, and we're currently feverishly writing an app which will allow people to, again, another way of accessing the resources, but this time on your phone. And be able to do the Q&A type stuff that I think that we all really, really need. So in those few moments, or in a clinic, you can just pull a resource up and look at it with a trainee, or look at it for yourself, and then go on and teach the training. I just want to finish with this. This is what I watch whenever I'm feeling overworked and stressed. Thank you.